class, we have discussed about last video. I have explained everything about Bode plot, advantages of Bode plot, procedure for drawing Bode plot. So Bode plot consists of two plots, magnitude plot as well as phase plot. So procedure also explained in the last class. Today's class we will discuss about the key factors for drawing the magnitude plot. Okay, so first we will take the constant term k. So here open loop transfer function, that is g of s into h of s equal to k. So if h of s equal to 1, g of s equal to k. It is having magnitude and phase. Magnitude k at an angle of 0 because it is a constant term. It is denoted by m mod g of j omega in decibels dB. 20 log k, it is a magnitude, and phase is phi at an angle of g of j omega is 0 degrees. For the different values of k, you can find magnitude and phase. At k equal to 1, magnitude is 0. 20 log 1 is 0, 20 into 0 is 0. So that is this line, 0 dB line. If k equal to greater than 1, magnitude value is positive value, 20 log. So more than 1, it may be 10. For example, if you are taking 20 log 10 is 20. It should be above this line, right? Above this 0 dB line, positive value. If it is in between 0 and 1, so magnitude you will get negative value. In between this you will get negative values. This is the magnitude plot. If you are taking phase values, whatever the value of k in between 0 to infinity, so all the values, phase, there is no change in the phase value, that is 0 degrees only. Because tan inverse this one 0 by k, right? Tan inverse, whatever the value it is, angle is 0 only. So that is the first factor. And coming to the second factor, when you are taking about s term, okay, that is in the numerator. Even similar way you can take 1 by s also. This one it is in the numerator, 1 by s is in the, that is s term is in the denominator. Similar way we can see. Here, after substituting s equal to j omega, so you will get here 0 plus j omega. Magnitude value is in decibels 20 log omega. And phase value is tan inverse omega by 0. Tan inverse 90, right? Tan inverse, which one? Infinity. Tan inverse infinity is nothing but 90 degrees. Okay. So now, at different values of frequency, we'll see the magnitudes, how it varies. At omega equal to 0.1 radians per second, magnitude is 20 log 0.1. It is a 1 by 10 or 10 power minus 1. Minus 20 into log. So that is minus 20 dB. If omega equal to 1, so log 1 is 0, 20 into 0 is 0. 0 dB line, this one. At omega equal to 10, magnitude is 20 dB. We can observe these values, 0.1, 1 and 10. Why you are taking this one? It is a 10 multiples. So the frequency range, W2, if you are taking a second frequency by first frequency equal to 10, so that is called 1 decade. During this decade, it is a one slope, you can see, 20 dB per decade. Okay, so this is the magnitude. Phase value, there is no change in the phase value, it is always constant, that is a 90 degrees, whatever the values of frequency. So this is the line, right? So the magnitude plot is a line which is having a slope of 20 dB per decade. It is a 1 decade, either this or this. The line started at 0.1 radians per second, having a magnitude of minus 20 dB, and it continues on the same slope only. It is touching 0 dB line at omega equal to 1 radians per second. In this case, polar, this is the phase plot is 90 degrees line. That is the another factor, that is S. Okay, G of S into H of S equal to S. We'll take another factor, it is first order term. Okay, so let G of S into H of S equal to 1 plus S tau. So after substituting S equal to J omega, the factor is 1 plus J omega t. This one also is having magnitude and phase. That magnitude in decibels directly 20 log. So this is the actual magnitude, square root of 1 square plus omega square t square. That is in decibels. Phase angle is tan inverse omega t by 1. Tan inverse omega t is in degrees. So we need to find out the magnitude value and also phase values. So here we are taking omega tau is very much less than 1 at that time. How much magnitude? So if it is very much less than 1, it is a neglectable value comparing with 1. So 20 log 1 is 0, right? Magnitude is 0 dB. If omega t is very much greater than 1, so at that time 1 can be neglectable in comparison with the omega t, right? So magnitude is 20 log square root of omega square t square. This square and square root cancel out, 20 log omega t. That is in t. Okay, this is the magnitude. So up to this, that is at first this value 1 over omega tau. So slope it is a varying. Up to this it is a 0 dB per decade, and from here slope is varying 20 dB per decade. Okay, magnitude plot is having 0 dB up to omega equal to 1 over tau radians per second. At this point, omega equal to 1 radians per second, it is having slope 20 dB per decade. In this case, phase plot, so it is same up to this omega equal to 1 over tau, it is having 0 degrees. At this point, so it is varying, that is it changes 90 degrees. This Bode plot is called asymptotic Bode plot. Okay, here when you are seeing this one is 0 dB, another is 20 log omega t. It is one is less than, another one is. So these 2 points somewhere it meets. That meeting point is called, okay, asymptotes. You can say here asymptotes meeting point. The frequency at which 2 asymptotes meeting point is called corner frequency or break frequency. So this value 20 log omega t, that is equal to 0. 0 is nothing but what? 20 log omega 1. So this one. Just you take this one, omega t equal to 1. So omega is equal to 1 over t, where omega is called corner frequency or break frequency. Okay, so this is the summary of basic factors. Whatever the factors we are taking, key factors, summary. First, we have taken constant term. It is having slope of 0 dB per decade, no corner frequency for the constant. So phase angle also 0. Okay, for the integral factor or derivative factors, if you are taking, I have explained about S, right? It may be S square, S cube, whatever the value, only difference is here multiples of n. If it is plus n, it is a slope of n times only, plus n into 20. If it is suppose minus means what? It is integral factor only, right? So j omega whole power minus n, that means 1 over j power this one only. So at that time you will get minus, right? Minus n into 20. So that is a slope. So for these 2 factors, no corner frequencies. It may be 1 by s or s. These factors, no corner frequency. Okay, only is having phase angle. Okay, if you are taking first order factors 1 plus st or 1 by 1 plus st, these factors, and second order factors, these are having corner frequencies. So slope it is same as first order factors, and these s power, that is s r 1 by s, these are having same slopes, that is a plus 20 dB per decade if it is in the numerator factor. If it is the denominator factor, it is having minus 20 dB per decade. So at that time, whatever the corner frequency where omega equal to 1 over t. Okay, radians per second. So phase angle same the way how we are finding. If it is the numerator, tan inverse omega t by 1. If it is denominator, minus tan inverse omega t by 1. Okay. If it is second order or quadratic factor, again same. If it is in the numerator factor, you will get plus 40 dB per decade. If it is in the denominator, you will get minus 40 dB per decade. The slope is this one, and corner frequency for the second order factor is omega n, natural frequency only. Okay, so that is the phase angle for these factors. If it is in the numerator, you will get here which one, that is the value. Similar way how we are finding tan inverse imaginary factor by real factor. Okay, thank you all.